Hello, dear friends. Today we are going to examine the inside of an electromechanical relay and see how this small component can control large electrical circuits. Relays are one of the most widely used components in industrial electricity, automation, and control equipment. They may look simple, but their operation is designed based on the important principles of electromagnetism. First, let's take a look at the appearance of the relay. This component is usually located inside an insulated plastic case that protects the internal components from dust, moisture, and impact. Now, using a razor, we carefully open the protective case so that we can see the inside of the relay. Removing the case reveals the internal components. The first important part you see is the relay coil. This coil is made of very thin enameled copper wire wrapped around a core. The function of the coil is to produce a magnetic field. When electric current passes through a coil, a magnetic field is created. In the center of the coil is an iron core. This core strengthens the magnetic field and makes the relay more precise and powerful. Next to the core is a moving part called the armature. When the magnetic field is created, the armature is attracted to the core. This mechanical movement causes the contacts to change state. The contacts are the parts that break and connect the electrical circuit. In simple terms, the relay acts like a switch, but instead of a human hand, it controls the magnetic field. For this reason, it is possible to control circuits with high voltage and current with very low current. Here you can see the path of movement of the contacts. By attracting the armature, the contacts are connected to each other, and the circuit is established. When the coil current is interrupted, the magnetic field disappears and the return spring returns the armature to its original state. As a result, the contacts return to their original position and the circuit is broken. Now, at this stage, we open the coil to better observe its internal structure. As you can see, the enameled wire is wound in a regular and layered manner. This type of winding creates a uniform and strong magnetic field. The very thin diameter of the wire indicates that the number of turns is very large, which increases the strength of the magnetic field. If this coil is damaged or disconnected, the relay will no longer be able to create a magnetic field and its function will stop. One of the advantages of relays is the electrical isolation between the control circuit and the power circuit. This means that sensitive circuits can be controlled without direct contact with high voltages. For this reason, relays are used in industrial electrical panels, protection systems, PLCs, and many control equipment. Despite the advancement of technology and the introduction of solid-state relays, electromechanical relays are still widely used due to their simplicity, affordability, and high reliability. In conclusion, we can say that this small component is a great example of converting electrical energy into mechanical motion. As you can see, when current passes through the coil, a magnetic field is created, the armature moves, and the contacts change state. If this video was useful to you, be sure to share it with your friends and follow the channel to see more tutorials in the field of industrial electricity and automation. Thank you for your support.